Hello everyone. In my next talk, I'll present to you TestCov. TestCov is not a test generator like the other tools we saw today and will see, but it's the tool that computes the coverage measurements in TestComp'. So every participant generates a test suite, and this test suite is then given to this tool, TestCov, for coverage measurement. I'm Thomas, the guy in the picture, and I'm one of the developers of TestCov. So very basic starting point. We have a program, we have a test suite that the participant generated, and we want to execute that to get the coverage. But unfortunately, it's not really that simple. There are multiple issues with programs in TestComp'. So we have extensive resource usage, like this while loop that runs forever and forks new processes forever, which will crash your PC very fast. And we have stuff that is malicious on the file system or that changes the state on the file system, like removing a file or generating a file. So we still want to achieve 100% branch coverage for programs like that, but we don't really want to use our system natively to execute a test suite that achieves that. So we could use stuff like virtual machines or containerization like Docker for that, but all of the existing solutions that we knew had potentially large overhead. For example, virtual machines required a manual setup, consisted of multiple different tools that had to be used, or required super user privileges, which is not easily possible on our cluster machines that run the experiments. So we thought of our own solution, which is called TestCov. TestCov takes the program under test, a coverage criterion. In TestComp, that's either coverage error or coverage branches, and the test suite that was generated by the participant. As output, we want coverage statistics. So first of all, the coverage measure for the coverage criterion, but also some other stuff that we may be interested in. And TestCov also gives us a reduced test suite. We achieve robust test execution through isolation provided by Linux kernel features. All of that isolation is already implemented in another tool that we use for benchmark execution called benchexec. And it uses control groups, or C groups in short, and containers, or namespaces. We isolate each individual test execution, and we protect against resource exhaustion. So we have maximum limits that are allowed for resource usage, like CPU time, memory, or number of processes spawned. We protect against file system modifications by using overlay file systems. So tools can read and write whatever they want, but whatever they change is only in memory for that single run. And we protect against dependencies between tests, because everything that is changed is only for that single test execution. We measure coverage with LCOV and GCOV, which provides us a very good tool for line coverage. But we want to have branch coverage and coverage for the reach error calls in coverage error categories. So we use our own instrumentation. We add labels goal_1 to n for n different goals to the program before test execution. And then we use LCOV and GCOV to measure the coverage of these goals in the program. In the end, TestCov produces different data from this coverage information. It gives us whether the test succeeded. It gives us the individual test coverage for that single test, the accumulated test coverage of all currently executed tests, the resource consumption per test execution, and it gives us all of that as JSON data, and in addition it provides us an SVG plot that shows the coverage of the criterion over time. In addition, it gives us the reduced test suite that I already mentioned, based on the previously collected coverage information. Now, if you're interested in TestCov and how to use it, TestCov is available open source online under the link that you see here. And if you have any questions or encounter any issues, don't hesitate to open an issue in the repository or drop me an email. Thanks for listening.